All right, C. Lindelof videos, more mixed chain rule problems. So here I'm starting to look at this problem, and we're asked to find h prime at t. So we're asked to find h prime at t here, and we're given that h of t is equal to the quantity of t squared over t cubed plus 2 to the second power. This is what I'm recognizing. I recognize that this is a chain rule problem. So I'm like, okay, this is, right, ddt, the derivative with respect to t of f of g of t. That is to say, if we have an outside function with another function tucked inside of it, is f prime at g of t, so the derivative of the outside function, times the derivative of the inside function. So that's all I'm going to do. I'm going to do a little bit of this thing called u substitution. I'm going to say let u equal g of x, and let g of x equal to, and I'm just going to take that difficult looking piece out, t cubed plus 2, and it says let u equal g of x equal this. So if that's true, then f of u would be, right, when I'm looking at it this way, I'm saying now this to me is u, so I have u squared, so f of u is u squared. Well, then f prime at u, the first derivative of that function, would be 2u, wouldn't it? I'm just using power rule there, right? So that's good. So I start to put my pieces together, right? I'm like, okay, now I need g of t. Well, g of t, look, I called this x, it's not, it's t. G of t is equal to t squared over t cubed plus 2. Now we get to the part that sucks, and that is g prime at t, because we look at this. All I'm doing right now is I'm trying to gather the pieces to use my chain rule here. As I'm gathering the pieces to use the chain rule here, I run into a quotient rule problem. And in the last problem that we did, it was very similar. We had a quotient rule problem that needed us to use the chain rule to get a piece for the quotient rule. This time, we need to use the quotient rule to get a piece that we need for the chain rule. So I'm just going to run through this thing, and I'm going to say, okay, so I'm going to start to pursue this. I'm forgetting about this part of the problem. I'm not thinking about this right now at all. I'm only pursuing this. So I'm pretending this is its own separate problem. I'm going to say it again. I'm pretending this is its own separate problem. So I'm going to do that. I'm going to say, okay, then f of t is equal to t squared. F prime at t is equal to 2t. G of t is equal to t cubed plus 2. You still with me? G prime at t is the derivative of this, so 3t squared. So now I have all the pieces I need, right, to get to work on this piece of the problem. Again, I'm not thinking about this thing yet. I'm just holding that aside. So I start to pull all this crap together, and I'm like, okay, I have g of t, so I have t cubed plus 2. That's the bottom function times the derivative of the top function, which is 2t, minus the top function times the derivative of the bottom function, which is 3t squared, all over the bottom function squared. So the bottom function was g of t, right? The bottom function and the top function here, right? So I'm going to take that and say, okay, I have t plus 2. A note of warning here, don't screw with this stuff at the bottom unless there's some great reason that you think that you're going to get something special out of it. Other than that, don't mess with it because it turns into, oh my God, it just turns into a mess. So now what I'm going to do is I'm going to distribute completely. I'm going to multiply this times this, then this times this. I'm going to multiply these two things together and distribute that negative sign inside. So I'm just going to do a little bit of algebra here. And I'm going to get 2t to the 4th plus 4t, right? Minus 3t to the 4th power. This is just me working on this top piece right here. I'm going to do nothing to the bottom part. I'm just going to leave it t cubed plus 2 squared. As I clean this piece up here, I'm going to get 4t minus t to the 4th, aren't I? All over t cubed plus 2 quantity squared. Like, what in the hell am I getting? You know what we got here? We got g prime at t. Who gives a crap about that? We said way up here that we're going to need g prime at t. So this is me gathering that up. So I'm going to go back now and I'm going to start filling in my blanks. Right? I'm going to start filling this in. it says here that I want f prime of this, so it's 2u, right? F prime at u is 2u, so 2u. Remember that u, we're going to resubstitute now, that u was t squared over t cubed plus 2. I'm going to put this in parentheses so you can see something a little bit more easily, right? So that this piece right here constitutes this piece right here, right? See this multiplication sign right here? That's this one right here. And we went through all that crap to get g prime at t. And g prime at t, if you remembered, was 4t minus t to the fourth all over t cubed plus 2 squared. Holy God. Right? Isn't that awful? Let me go back and check that piece of math, and there it is. Good. Right? If you wonder why I switched positions here to here, I was trying to not lose this negative sign, so I just tucked it in there to make sure I didn't lose it. Now I'm just going to do some math. I'm going to, look, this 2 is 2 over 1, isn't it? So I'm just going to multiply straight across. I'm not going to multiply into there, but I am going to start making my declaration that I believe I have finally gotten h prime at t, which is 2t squared times 4t minus t to the fourth. Look at this for a second. 1 times t cubed plus 2 is t cubed plus 2. But this is this to the first power. These two factors match. I have to the first power here, to the second power here. That gives me to the third power, doesn't it? T cubed plus 2 cubed. Is there anything else I might do? Yeah, I guess I could factor out a t's from here. So I could turn this into t, this into t cubed, and this into t cubed, I guess. Would work, wouldn't it? I think that's a good answer. I think that's the answer that I'm going to stick with. So, look, I hope this was really helpful for you guys. I really do. I know it's a pain. Don't give up on this. Let me tell you, this saying is so stupid. You know, practice makes perfect, but there is some truth to it, and this is something we just have to grind through it over and over again, and all of a sudden it will sink into your mind. It'll be a thing of beauty. So, thanks for watching. If you have any comments, please make them, and if you haven't already subscribed, please subscribe. Thanks, you guys.